Hey guys, we're going to be looking at recurring decimals of fractions. Very quick tutorial. So first we're going to look at the recurring decimal 0.2 recurring, which means 0.2222, and that goes on forever. If that was just 0.2 by itself, that'd be nice and easy because it'd be 2/10, or you put on your calculator and let that do it. Unfortunately, it's not as simple as that with pen and paper, and your calculator won't do it for you. So what I'm going to start by doing is I'm going to use some algebra. I'm going to let x equal 0.2222 ... Then I'm going to let 10x. Now, I get 10x by timesing x by 10, so I'm going to times this by 10 as well. If I times this by 10, decimal point moves one spot, so I get 2.2222 ... Now you might think, why on earth have I done that? Okay, so the next step, hopefully you'll start to see why. I'm going to subtract the first from the second. Okay, so 10x minus 1x is just going to be x, 9x, sorry. And then 2.2222 minus 0.2222 is just going to equal 2, because that, take away that, disappears. And hopefully you can look at that and now see why I've done that. Because now it's a simple process of dividing it by 9 to getting x equals 2 over 9. And I've got my fraction. And if you wanted to, you could chuck that into your calculator, press your SD key, and it will come out to be 0.22222. That's what I like about this stuff. If you've got a calculator, you can just make up your own ones. Just make up your own numbers, like 0.1 recurring, 0.3, 4, 5, 6, etc. And then you can check it in your calculator. Okay, so the next one I'm going to look at a double digit this time. We're going to look at, for number 2, 0.34. I'm going to recur both of them. So each time, we're going to start off the same way. X equals 0.3434. I like to have 4 decimal places and ... Now, at first, it's probably good to do 10x, but later on, we get more, a little bit more confident with this stuff. You might start missing steps, which is fine. So let's times this by 10. Move that one decimal place. I get 3.4343 ... Now, you might notice something, that these decimals here and these decimals here are not the same. They don't match up. So if I subtracted these two, it's not going to leave it just to be like 3, for example. So what I'm going to do, and often you can just keep on multiplying it by tens. I'm going to times it by 10 again. So now I get 34.3434 ... And the whole aim of this is to find somewhere where I'm going to have those decimal points to be the same. So you can see now, for this particular example, the x and the 100x works. Now, if 100x didn't work, I might chuck in the 1000x, okay, and see what happens. But 100x does work. So 100 take away 1 is 99x. 34.3434 minus 0.3434 is just going to equal 34. Therefore, x is going to equal 34 over 99. Sometimes this might be able to simplify it down. In this case, it's not, because only 2 goes into that. Okay, that's a double digit recurring. They do get more challenging, I'm afraid. Okay, I'm going to look at the next one, 0.15 recurring. But what you'll notice that this time only the 5's recurring. So my question is going to look like this, or my decimal is going to look like this. Okay, so how does that change it? Well, let's start by doing the same steps. 0.1555 ... Now I'm going to multiply it by 10, like I would normally. All the same steps. 1.555. Okay, at this stage, I look at this and go, that's not working. Okay, that hasn't worked. So I'm going to do 100x now, like we did the last example. So times by 10 again, 15.5555. And then we look at it, and hold on, here we go. We got these ones, and these ones are the same. Now this time you'll notice that the top one we're not using. So it's not always going to be using the x. It might use a 10x, a 100x, might even use a 1000x. In this case, I've got these two the same. So 100 take away 10 is 90x. 15 take away 1 is going to be 14. And again, because they cancel out. So x is going to equal 14 over 90, which could simplify it down. Let's halve it. 7 over 45. And that's going to be my simplified fraction. Once again, I can put that in my calculator, press the SD key, and hopefully 0.1555, that will occur. Okay, so that's a much more challenging question. And let's go one slightly harder maybe. Okay, this will be number 4, I believe. Let's go 0.123 recurring. And let's recur the 2 and the 3. Okay, so once again, all the steps are the same. X equals 0.1. Now this one might do 5 decimal places, just so I can see the 4 recurring. I'm going to do 10x to make it 1.2323. Okay, they're not the same, so let's go to 100x. 100x equals 12.3232. Now, I did say it's going to be a little more challenging. I've done 3 of them, and look, none of the decimal places currently recur or are the same. So I'm going to go to 1000x now. So I'm going to go 123.2323. Now what we've got, if you look at this, I've got the 2323, the 2323, so I'm doing 100 and the 1000. Okay, so 1000 take away 10 is 990x. The 123.2323 take away 1.2323 equals 122. So x equal to 122 all over 990. Now again, I could halve that if I wanted to. So it's going to be 61 over. It's going to be. So it will be 495, I believe. I hope that's right. I'll do that quite quick. Okay, and I've got my simplified fraction. Okay, so you can see that's how recurring decimals of fractions work. Hopefully that gave you a bit of a basic introduction to that. Well, as I said, just try it. Chuck in some numbers, see what happens in terms of, just go 0.23, recur both of them or recur one of them, and then, find out what the fraction is going to be, test it on your calculator, see if it's right. That's the best way. Okay, practice makes perfect. Hope it made sense. Any questions, drop me a line.